We are on to the third day of section 7.3, which is about still solving systems of equations like you see here. We are just going to do it in a little bit different method for today. In the last couple of days we did row operations, we did matrices, and then used row operations. Today we're going to do something called a matrix equation. Now a matrix equation, the basics of it start with a very simple equation, AX equals B. We're going to set up this system of equations in a form like this where A, X, and B are all individual matrices. A is going to be the coefficient matrix. Over here I'll show you an example of each one of these things. X is the variables, B is the column over on the left. So we're going to first of all set that up, put it into a matrix equation by starting with A. Now A is the coefficient matrix. So that means we're going to have all the numbers that come from X, Y, and Z in these equations. So you'll notice that we have 1x plus 4y minus 2z. That's all right here. Here's our second row, here's our third row. So that's going to represent just the numbers on the left-hand side. After that, we're going to do the variable matrix, which the variables in this system are just x, y, and z. So according to the rules of matrix multiplication, we're going to arrange that in a vertical column, and I'll talk about that in a second, why that works. And then the third matrix that we have is just the right-hand side, which is the numbers over on the right-hand side of the equals sign. That is our matrix B in this case, and this is a matrix equation. Now, why does this work with matrix multiplication? I just want to remind you that when we do multiply two matrices together, we have to start with their sizes. A is a 3 by 3 matrix. X is a 3 by 1. Remember that what we multiply together, the middle numbers have to match up, and they do in this case. And then that means that the result is a 3 by 1, which happens to match up with what we have over here. So this now represents the equation that we're going to be working with. Before we do the actual example, though, I want to just walk you through why this method is going to work through this. Now, just the generals about a matrix equation. What we have here is we have this matrix equation, like I mentioned, AX equals B. X is the variable, is the matrix for the variables that we're trying to find. So in a normal equation, if I had something like 6x equals 12, I would want to find out what x is. So I would probably divide by 6 on both sides. Well, it would be nice if we could do that with matrices, but unfortunately there is no such thing as matrix division. And so we're going to have to rely on something else. But let's just say here we've got that AX equals B. The equivalent of matrix division is just going to be using inverses to get rid of some things. So here's what's going to happen. Now we're going to take A inverse, whatever that happens to be, and we're just going to do the same thing to both sides of the equation. Notice that we have A inverse. We're going to be multiplying by that on both sides. Now, if I do that over here, A inverse times A, if they are truly inverses of each other, what ends up happening, we multiply those together and we just get I. I is like the number 1 when we're talking about matrices, and so that just sort of goes away, and that just leaves X on that side. So that means that our solution, depending on what these matrices are, is just X equals A inverse times B. This is kind of our key thing, our key equation when we're solving matrix equations. So we're going to go off of this as our big deal in terms of how to solve a matrix equation. Now the nice thing about these is that we're going to let the calculator pretty much do all of the work. So here is that matrix equation. Now I have already put these matrices in my calculator. If I go to second matrix, just want to show you that I've got these matrices in there. I'm going to go to the first one, A, and I've put in the same matrix as what you see here in the coefficient A. All right, then also I want to show you that I have B in there. The right-hand side of the equation, 0, 6, negative 13, so you can see that that one matches up. We are going to, we can just find A inverse and then multiply, but we can also just let the calculator do all the work. If we wanted to find A inverse, that's what it would be. So I did this using the calculator, and now we multiply it by B. That's going to give us our solution to this system. Well, if I do that on the calculator, if I just go to second matrix and I type A, I'm just going to go A inverse and then multiply it by, back to the matrix, B. This should be my solution. It looks like we get 3, negative 0.5, and 0.5. All right, so that's what I also had here. And what you'll notice about this then is that these represent X, Y, and Z. So I'm putting my ordered triple right here. 3, negative 0.5, and 0.5 is the solution to this system, and you can check that very easily just by plugging them in. I'll let you do that if you like.